period, we talked about the mole. Tell me what a mole is. You make me proud. So a mole is 6.022 times 10 to the 23rd. That is literally, it's literally just a number. Everyone agree with me on that? Just like a dozen is 12, a mole is 6.022 times 10 to the 23rd. Can you write that on the board just at the very top, just so we have that as a going to? And I'm gonna focus on you right now, Jacob. You're gonna be my screen. For some reason, there you go. Can you write 1 mole is equal to? And can you make it 6.022, not 6.02? Now, what that is 1 mole is it? Come on now, kiddos. 1 mole, you with me, Lindsay? We're focusing right now, right? 1 mole is equal to 6.022 times 10 to the 23rd anythings. We call them particles, right? So depending on what our particle is, they have different names. So if I have a molecule, right, then it would be 6.022 times 10 to the 23rd molecules. If I have an element, then it'd be 6.022 times 10 to the 23rd atoms. If I have an ionic compound, it would be 6.022 times 10 to the 23rd formula units. Do you guys understand that there's 3 different? So can you write particles next to it? On the right-hand side, right-hand side. So what I do here. And can you do like a little parentheses opening up to the right? Okay, by like one that does like this, so I can put like 3 things next to it in a row. Yeah. Okay, and on the top, can you write atoms? Next, write molecules. And lastly, write formula units. Okay, so those are the 3 main things that we're going to be using, yeah? And the conversion is literally a 1-step conversion. I give you moles, you use 6.02 times 10 to the 23rd to figure out the atoms, molecules, or whatever the compound is. Hey, come on now. Or I give you the number of particles of something. If I tell you I have, let's do this together. Let's do, I have 2.79 times 10 to the 26 formula units of NaCl. Yep. It's actually FMU, formula mass units. Yeah, let's just get that on tape. So yeah, the abbreviation for formula mass units is FMU. It's also known as atomic mass units. Let's not abbreviate it FU. All right, formula mass units. Can you put an arrow and go question mark? Formula units of NaCl. Of NaCl. And then go question mark. A is a lowercase, and the L is a lowercase. A little arrow, question mark, moles of NaCl. So in all of our problems, we're always going to start with whatever they give us, right? So we're going to put it in the upper left-hand corner of our table. So let's start with the 2.79 FMUs, 2.79 times 10 to the 26. Michael, if you need anything, just okay. Right, FMU, NaCl. And make the line all the way across, and then make a line vertical down. Okay. Now, the conversion we're going to use for all these, isn't it 1 mole is equal to 6.022 times 10 to the 23rd of whatever it is? In this case, isn't it formula units? So we want to cancel out formula units. So when we look at the puppets right here. If I have 1 mole and I have formula units, we're either going to put the 1 mole on the top and the formula units on the bottom, or the other way around. We want to cancel out formula units on the top. So where are we going to put the formula units in our conversion? On the bottom. So let's put the 6.022 times 10 to the 23rd. Nope, 1 step over. There you go. 6.022 times 10 to the 23rd FMU NaCl. NaCl times 10 to the 23rd. Do you need to sit closer to the front? You got it? Okay.
Wait, I thought 1 mole was. We don't need to really plug it into the calculator.
And then on the top, write 1 mole NaCl. Yes. Okay, so there's 2 ways to do this. You guys have really fancy calculators, right? So you guys can actually plug in the exponents into your calculator. You can actually do that. You can actually write the number in with the exponent and the number with the exponent and hit equals, and it'll give you a number. Typically, they don't give you the number with the exponents on the bottom. They'll just give you a decimal. But the way I like to do it, just because some of us aren't that familiar with it, is on the end here, would you agree with me that FMUs cancel? Let's put a line through those. And can you shift the screen, or maybe move your laptop more to the right? That's because that's really, really hard to see. Can you write equals and then put FMU NaCl as your final answer? On the right hand side, leave a space and write FMU NaCl, because we want to take care of the units first, and we all agree that the formula mass units are the only units that are left standing right now. Yeah. Then we want to take care of the exponents. I'm going to do it the old school way. I'm going to take care of the exponents first before I punch it in the calculator. So don't I have 10 to the 26 on the top and 10 to the 23 on the bottom? And when I have exponents on the top and the bottom, what do I do with them? I subtract them. Since I'm already hogging this space here, Michael, that's a great idea. Just do 3 there and 1 there. Thank you. And the burettes are in the back cabinet underneath. The holders are there too. The clamps are there as well. The clamps may be in the back, but yeah, they should be there as well. All right. So can we write 10 to the 3rd as my exponent? Because we just subtracted them out. So we write 10 times 10 to the 3rd. Okay. Now, I did this stepwise. You could have punched in that whole number on your calculator, including the exponent. Can I get ahead, Bob, if you're with me on that? But if you do it stepwise, now all that's left, isn't it 2.79? I'll get you just a second here. Let me just finish that. 2.79 on the top, and don't have 6.022 on the bottom. Let's just divide that. Can everyone right now pull out your calculator? You need a calculator to do these problems.
Oh, wait, never mind.
What do you end up with?
464.845.
464.845?
464.8.
Whoa, hold on. Nope. You did it with the actually put the exponents in. So I want to do it without the exponents first. You're right. So let's try this. Let's just verify. Let's do the numbers by themselves. So everyone on your calculator, just to make sure we're doing this. Let's go 2.79 divided by 6.022. What do you get? 0.4. Can you write in front of it? 0.46. Can you read it again for him?
463301.
463301. Can anyone else verify that with him? Okay. Would you acknowledge what your answer is going to be is you're going to get the same answer, but because yours is an exponent, it ignores the 10 to the 3rd.
I didn't get the 1. I got 4.65 when I did it.
Well, let's try and do the numbers again, because that shouldn't be the case.
Yeah, I got
463.3, which is that right there. Okay. Now, let me show you how this works, though. And the answers are going to be the same. Let me show you how it matches. So is that good form right there? No, we want to shift the decimal place over 1 place to the right, don't we? So do me a favor, shift it over 1 place to the right. Righty what? Righty reducing. So wouldn't that be 4.63301 times 10 to the 2nd? Agree? And then let's take a look at the number of figures we actually have in our number. How many significant figures do we have in the 2.79? 3, right? That's the lowest number. The 1 mole, by the way, is an exact number. That's never going to be the significant figure counter for us. Okay. So can you draw a line after between the 3 after the first 3? So it's going to be 4.63, and then that 3. Does it tell anything to round up or round down? No. So we're going to write 4.63 times 10 to the 2nd. Now, those of you that did this on your own, isn't 4.63 times 10 to the 2nd, isn't that exactly the same thing as 463? So if you did it on your calculator with the exponents, you're going to end up with 463. Now, I think, Lena, you said, Lina, sorry. Almost as bad as not knowing his name. I think that you said 463.3, right? Yeah. And that would be great if we had 4 significant figures, but we still want to take care of significant figures. Okay, any questions on what we just did there? Okay, so now what we're going to do is we're going to go a different way. So we can go back and forth. Would you agree with me? Can you put out like a box in a different color around the 1 mole equals 6.022 times 10 to the 23rd? So that's one of our go-to conversions. You got to memorize it. You got to have it ready. Okay, all particles. Put particles in there. Okay, and now what we're going to do is we're going to go between moles and grams. Another conversion. So let's do this. I want you to put particles in a circle on the right-hand top of the screen, or top of the board. I want you to write the word particles and circle it. And put a back and forth arrow about this long, and then write moles. Circle it. And then put a back and forth arrow and write grams. And circle it. Okay, so put your finger on the moles in the center, please, for me. And can you maybe scoot the screen over? Like, I'll put it, like, actually lift it up and put it right on the center of the table, right next to it. Okay, watch. I want to make this really simple for you because all we're going to do is one different conversion. Okay, put your finger on the moles, please. Okay, finger on moles in the middle. Okay, what we've been doing yesterday and today, haven't we been going back and forth between moles and particles? Put your finger back and forth, simulating what we've been doing. Haven't we been going back and forth? And on top of that arrow, can you put at 6.02 times 10 to the 23rd per mole? Like a little slash and then go. And then put a little slash underneath it per mole. Isn't that the conversion we've been using to go back and forth? Or another way of saying it is, we can either put the moles on top or the number on the top, but we can go back and forth forever. Now, I want to go from moles to grams. And the way we do that is by using something called molar mass. Now, watch what they did. Do you guys have a periodic table that I gave you from the previous test? If you have a periodic table, pull it out. If you don't, there's some extra periodic tables right here. Can you guys have one in your hand so you can look at this up close? Can you pass these out here? You'll have to give this back to me, or you can open up your textbook and have it. The periodic table actually is really, really impressive. Everyone have a periodic table right now? Okay, can you pick up the laptop and walk right over to the periodic table? Have it in your hand so you can kind of see the periodic table. Okay, move it kind of close to the periodic table and put it right next to where there's carbon up above. So if we can focus in on what carbon is. Okay, so really quickly, if you put your finger on carbon, do you guys see how carbon has a number below it that says 12.01? If you have a really, really fancy one, it might say 12.0108. Now watch. What that number is, that's the number of grams in 1 mole of that particular element. So watch me for just a second. I'm going to go back to me so you can put it down for just a second, Jacob. I'm going to screen on myself, just so you guys can see. Okay, everyone watching me here? Incredibly important. Here's what they did. They scooped up 1 mole of atoms, and they put it on a scale. Now, isn't 1 mole 6.02 times 10 to the 23rd atoms? So they took 6.022 times 10 to the 23rd atoms of carbon, put it on a scale, and when the scale measured, it measured 12.101. They did that for every atom, and the number underneath the element on the periodic table in every single case is the number of grams for 1 mole of that thing. Now, some of you guys may think, wait, how could you have 1 mole of carbon have a mass of 12? And what's the number underneath nitrogen? Isn't it 14.0? 14.0. Okay, show it right there if you wouldn't mind. So how is it possible that 1 mole of carbon is, scoot it down just a little bit so we can see the number. Okay, how is it possible that carbon, 1 mole of carbon atoms has a mass of 12.01 and 1 mole of nitrogen atoms has a mass of 14.01? How is that possible? They both have the same number of particles, right? Let me ask you this question. Is the mass of a dozen elephants going to be the same as the mass of 10 tennis balls? I'm sorry, a dozen elephants versus a dozen tennis balls. Are they going to have the same mass? Why not? Because they're different. If I have a dozen of one thing and each one of those things is heavier, won't they have a different mass altogether? Are you guys with me here? You can put it down now for a second. I know that's probably hard to hold up there. So watch. Here's what we're going to do. Those numbers on the bottom of the periodic table, that's called the molar mass of those things. It's called the molar mass. And what that is grams per 1 mole of that thing. So can you do me a favor? Can you erase all the stuff that's below in brown? And I'm going to show you, I want you to write, let's write the mass, the molar mass of carbon on the board. Okay, so we're going to write 12.01 grams and then write equals 1 mole. Do you realize that now is a conversion factor? 12.01 grams of carbon is equal to 1 mole of carbon. Just like 1 foot is equal to 12 inches, right? We now have a conversion. So wait, what if I were to tell you, wait for it, I got 2 moles of carbon. What does that mean? What would the mass of it be? Wouldn't we have to multiply the 12.01 by 2? So just like we did conversion before, don't we have another conversion that's available to us? Every single element on the periodic table, that number is the number of grams per 1 mole of that thing. So you have a conversion factor for every single one of them. Put your finger on oxygen really quickly. What is the number underneath oxygen? 15.999, right? Or if you round it at 16.00. You know what that number means? 15.999 grams of oxygen for 1 mole of oxygen. That way, you can convert between grams and moles because you have it on the periodic table. Can I get ahead, Bob, if that's the truth? Yes, sir.
Are we going to have these converted chart or anything like that?
You're going to have a periodic table in your hands.
Okay.
So if you have the conversion, if you have the periodic table, doesn't that automatically? Now you have to know, you have to remember that that's always grams per 1 mole.
I'm not like, are we going to have a formula chart with like 12.01?
No, that's on the periodic table.
Oh.
So take a look at carbon. If I ask you to do the carbon moles, that you just look at the number down below, and that's the number of grams per 1 mole of carbon.
Oh, okay. I see.
Do you guys see this here? So it's not like a magical table. Your periodic table is that magical table, and every single number underneath there, that is the grams per 1 mole of that thing. So you can convert anything between grams and moles as long as you have your periodic table. Okay, you had a question, Caroline?
So this stuff is going to be on the test too? 'Cause we're
Two separate things. We have a test on Friday, and we have a test, the makeup test, retake test, and Ian will tell you about it in just a second. Or if you already probably told you about it.
I'm not going to be here Friday.
So then you can take it sooner, and there's all kinds of other stuff. All right. So how does this work out? Let me give you a problem. Ready? Given. Let's do a problem with this. Given 6.82 moles of carbon, how many grams? Oh, by the way, instead of saying how many grams, do you realize I can ask what's the mass? Can you guys get that correlation? Mass and grams are the same thing. Grams are the unit for mass. So if I ask you solve for the mass of something, it's the same as saying solve for the grams of something. But see, formula units are one step away. Can we convert directly from grams to molecules? No, because you have to first see the table up above. Put your finger on the moles on the table. Can you maybe all the way over to the far right hand side? Okay, see that moles in the center? That is like a graphical chart of where we can go. So if I'm at moles, I can go using 6.02 times 10 to the 23rd. I can go to particles. Or put your finger on moles. You can go between moles and grams using molar mass. Can you write molar mass on top of that arrow? Of course, it's not showing right now. Molar mass. What is molar mass? That's the number on the bottom. Is everyone with me on this? Because I don't want you to mess up on this. Don't be frightened by molar mass. Molar mass is literally the number on the table in grams per 1 mole. So let's take a look at this problem right here. Aren't we at moles and we want to go to the grams? So in order to do that, we use the molar mass. Where do we find the molar mass always? periodic table. So let's start off with our table like you've been doing, Jacob, the 6.82 moles, and just write 6.82 MOL. That's actually the abbreviated unit. And then put the letter C, capital C. And then let's do our table. And where do we want to go right now? From moles to what? Grams. So we have to have the conversion. Where do we find the conversion between moles and grams always? Periodic table. Can I ask you to do me this favor so you never make a mistake? Do you understand whenever you use the periodic table, it's always going to be grams per 1 mole. If you ever put 12.01 moles per 1 gram, if you ever have any number other than a 1 next to your moles, you've done the problem wrong. Can I get a head bob on that? So in this case here, we looked up on the periodic table. Can you put your finger on the 12.01 grams equals 1 mole, please? We got that from the periodic table, agree? So all we have to do right now is set that up so that the moles cancel. So we are always able to do this. Look at me for just a second. Are we always able to put moles on the top or moles on the bottom, depending on what we want to cancel? In this case, what do we want to cancel on top? Moles. So how are we going to put the 12.01 grams in the moles in this to cancel out the moles? 1 mole on the bottom. Very good. I'm proud, guys. 1 mole of carbon on the bottom and 12.01 grams of carbon on the top. Just write the, you can just write letter G. Let's start abbreviating. And letter G for grams. And instead of writing MOLE, we don't have to put the E on the end. So that's super great. I know, right? Okay, equals.
81.9.
Yes. Do me a favor, before we do that, can you write mole and can you put a C next to the mole down below? Yeah. Okay. And then can we cancel the moles of C on the top and the bottom just so we know that they're no longer there? And that G you put, the unit for G, it's always a lowercase g. Capital G, do you guys remember that's a prefix that we use for giga? We just don't want to have that mixed in there. And you said you got what number here, Lina? 81.9 grams of carbon. Come on now. It's not bad, is it?
Oh, no.
This is, again, it's just a one-step conversion. Now, you know what the hardest thing is going to be? And we're going to do this next class period. I'm going to force you to go from grams to particles. And you know what we're going to do? Is literally going to be grams to moles, moles to particles. Or particles to moles, moles to grams. Literally, it's a two-step process. This is like, if you're like trying to like buffer your grade for the quarter, this is the test to do it on. Because we're not giving you any other content other than these conversions. So as long as you have a periodic table and you can write these conversions in, there's no way that you shouldn't be able to knock this out of the park. Now, if you do have trouble with this stuff, come in and get help or email me and let me know that you need to meet with me and I'll try and find time to meet with you. I don't know what has been. Everyone that sat at that table has clipped themselves over and over again and realized, oh, that hurts and stopped doing it. It's, yeah. Any questions on this? Yes, ma'am.
Why is it 81.9? Is it because 3 is really big?
Yes. Yes. Now, there's no reason to put this into exponents because there are no exponents, right? So I just multiplied this 6.82 by 12.01. Now, if you did that, you probably got 81.9. What did you get? Was there another number after it? 0. So 81.90? If it's 81.90, that 0 is going to do nothing to round up the 9, right? And it's just that we're allowed to have figures in our problem. Are we with me? Okay. Now watch. This is one step more difficult, and I don't want you to get confused. Okay? One step more difficult. Do you realize that? Oh, by the way, I could have gone backwards, right? Couldn't I start with grams and ask you to go to moles? Do you want to do one of those?
Yeah.
Yeah? All right, let's try it. Let's do this. So erase everything, including the carbon equals whatever, and let's go like this. Let's go 98.79 grams of 79 grams of sulfur, arrow, question mark, moles of sulfur. I want you to set it up on your own, please. You can do it on the board. And you know what the cool abbreviation is for moles? MOLS. Yeah, it's super great. What's that? Yeah. Moles of S. Grams to moles. We don't have to worry about formula units because formula units is only when we're going from moles to particles. We're not going from moles to particles. We're going between grams and moles. If you're wondering here, Jacob, can you put your everyone stop for just a moment here? Can you put your finger up there on the table? on the flow chart. That flow chart might be helpful for you. Are we starting in grams in this case? When we go from grams, where's the first step and the only step we can go to? Moles, right? Now, if you start talking about formula units, isn't formula units one step past that? I'm not asking you to do that right now, am I? So the only thing that you can do is to go from grams to moles, isn't the molar mass? So let's set up our problem, the 98.79 grams in the upper left-hand corner. Okay, now help me out. Don't we need the molar mass of sulfur? What's the number for the molar mass in sulfur?
32.06.
Okay, now here's what's really important. What are the units for that? 30, what is it? Point grams per what? 1 mole. That's the conversion. So it's actually 36 point, can you write that down? And by the way, where are we putting the grams in this case? Bottom, right? So we're going to put 36 point, I don't know the number, I keep on forgetting.
30.1, or it's
Let's do 4 significant figures if we can. 36 point, that's 3.
oh, point
36.06?
or 07 or 07.
32.066. So let's go 32.07. I probably misspoke it if 32.07. What did you keep it all in there? Now you can. What that's going to mean is that your number at the end is going to be slightly off. Okay, that's super important. Let's put the units next to it. What is that? Isn't that grams of that sulfur? And on the top, what are we going to put? 1 mole. Again, don't put any number other than 1 next to the mole. Are you hearing me here? I cannot. That is literally the most common mistake. We get students get a little flustered and they go, oh, 32.07 moles per 1 gram. And they put that into their problem. And their problem is always going to be off. Why do we set the grams of sulfur on the bottom again? Cancel. Let's cancel the grams of sulfur. And I'm a big fan of, that's a mole of what? Kangaroos? Or sulfur. Yeah, a mole of sulfur. Keep that in there. Now, at this point, you probably can get away with not doing it, but you realize that after this test, we're going to take this and do more with it, right? So I want you to feel comfortable with this. Okay. Did anyone actually do the math on this? Oh, what canceled? Grams of sulfur, grams of sulfur. Let's get that out of there. Agree? 3168 point. Oh, yes. You're dividing the two of them, right? 3 point. Say again. And by the way, that's a good check there. If you're like dividing, you should end up with a number that's bigger than what you started with. If the number's on the top and on the bottom, it's dividing. So this problem is 4 significant figures because we started with 4. Put your finger on the first number there, please, Jacob. We started with 4, and we had 4 in the from the periodic table, and we keep up 4 in our answer. All right. So I feel pretty confident you can go back and forth with these. Yeah. I'm going to make 1 level more of difficulty, and if you get this, literally, this is the hardest thing on the test. Okay. So do you realize that compounds, we don't just have atoms that we deal with, don't we have molecules sometimes? So do me a favor here. I want you to tell me what the molar mass would be of CO2. Because I want you to erase this, and I want you to write for me. Erase this off. Now, here's where I want you to all to take a brain pause and go, this is not hard. If I know the molar mass of each individual element, couldn't I add up the individual elements in a compound, their molar mass, to get the overall molar mass of the compound? Write CO2 on the board. Okay. Okay. No. Thank you. CO2. Now put a little line underneath it. Okay. And this help me out here. Would you agree with me that there is, can you write C equals 1 or C times 1 underneath? Like go C times 1 equals, and then could you write oxygen times 2 underneath it? Equals. Okay, really quick. Are you all acknowledging here? If I have CO2, isn't that really 1 carbon and 2 oxygens combined in a compound? Now follow this here. Let's just say that Trevor and I and Trey, we wanted to get our combined mass. You know what we do? Oh, no, you know what? You tell me what we do, because that is that simple. If the 3 of us wanted to get our overall mass, what would we do? That'd be really bad for them. If I want to figure out all three of our combined mass, want to go, what's your mass? Well, you don't know in kilograms, but let's say that he weighs 60 kilograms, right? And you weigh 65 kilograms, and I weigh 100 kilograms, or 150. Okay, 150. I weigh 125, right? In order to get our combined mass, don't I just go yours plus mine? Let's just pretend that you guys had the exact same mass. You're identical twins in every way, right? You have the same mass. Could I just go 2 times their mass plus my mass? Isn't that what we have for CO2? Don't we have 1 carbon and 2 oxygens? So do me a favor. All we're going to do is we're going to add up the molar masses. So isn't the molar mass of carbon, isn't it 12.011? Can you write that down next to it, 12.011? And oxygen, what is this individual molar mass? Isn't it 15.9994? Can we just do 16.00? Can we round it to that?
We don't round it wrong.
No. In fact, whatever I give you in the test, I want you to use all the numbers. So that's 16.00, right? But aren't there 2 of them? So can you do me a favor? Because I want it to be symmetrical so we can actually see. Right next to where it says O times 2, I want everyone to understand that 16.00 represents the O. And then don't we have to multiply that by 2? You're right. Can you show that we multiplied it by 2? Can you put like in parentheses and then go times 2 just so we see that we, yeah. Or just go times 2. Just go times 2 is equal to 32. Now, if I add those 2 together, so put a line underneath that. So put a plus sign to the outside of, like, you know, you do the plus sign on the left-hand side, on the outside of the O. So you're adding C to the O's, right? Wouldn't that be 12.011 plus 32? And that's going to give you 44.011. Can you write 44.011 on the bottom? And what that is, and here's where you have to be careful. So weren't these just molar masses on the periodic table that we added together? And aren't the molar masses always grams per what? Per 1 mole. So when we have CO2, that 44.011 grams, that's 44.01. Can you put letter G? And then write the per, so like a slash, per mole. So do you realize that now we can use that conversion to go back and forth between grams and moles? I want to pause right now because this is the one linchpin. If you can understand how we get multiple atoms together and we add up the molar mass to get the overall molar mass, then we can do moles to gram and grams to moles of compounds as well. Any questions on what we just did there? Okay, so watch. Now let's do a problem. Given, right up above, like beside it, given 6.39 moles of CO2 arrow, question mark, how many grams? Thank you so much, Michael. Of CO2. So can you do me a favor here? Everyone pause this for a moment. Can we look at the flow chart? Where are we starting this problem on our flow chart? Where are we starting? We're starting at moles. Put your finger on moles. What are they asking us to go to? Grams. So why do we do that? Don't we have to use the conversion of molar mass? But in this case, is it the molar mass of a single element? No, it's the molar mass of 3 atoms together. Can you make this really simple for yourselves? If you have more than 1 atom, you just add up their individual molar masses. We already did that, didn't we? So now let's set up our problem. Can you start with 6.39 moles in our table? 6.39 moles of CO2. To the table, dude. Wonderful. Now, do we have a conversion between moles and grams for CO2? Didn't we figure it out just a little bit ago? That right there, right? So now watch. Isn't that 44.011 grams? Isn't that equal to 1 mole of CO2? So don't we have the option now to put one on top of the other or the one on bottom? Which one are we going to put where? 1 mole on the bottom, right? Does everyone see why? We want to cancel out the mole of CO2. So can you put 1 mole of CO2 on the bottom? I really want you to keep the units there if you can. And then what's the number? 44.011. grams of CO2 on the top. Does everyone see that? What do we cancel right now? Moles. Cancel moles. And isn't the unit grams of CO2? So let's put our unit over there, equals. And then aren't we, and Caroline, just to be clear, the numbers that are next to each other, we multiply. The numbers that are above and below, we divide. So we're going to go 6.39 times 44.01.
Mr. Dimitrovich, do you want large test tubes or small test tubes?
Larger ones.
Okay.
Yeah, they should be in the left drawer, like the 15 by the left drawer, I think, has them. Anyone have the number on that for me? Go ahead. Bobby, can I thank you? You've been on fire today. I really appreciate that. I'm even going to forgive you for wearing your hood during class. Do you hear me? I'm even giving you a pass on wearing a hood in class today because you've been that helpful. If you're that helpful, you can wear a hood every day. All right. How do we feel about the number of significant figures in that number? Not great, right? Because don't we have, when we're multiplying, don't we have 3 significant figures in the first one? Yeah? So where are we going to draw our line of death in this one? After the 281, right? So our answer is going to be 281. True? Okay. Of CO2. Let's keep the CO2 in there. All right. How do you feel about this?
Wait, do you not have to convert a particle to moles?
No, because they didn't ask us to go that. Oh, if they ask it, so watch. Her question was, where do particles fit in? Nowhere. Put your finger on moles. Where did they ask us to solve the problem? Go from moles to where?
Right, but like, are we ever gonna have to?
Yes, but I want you to feel really comfortable just going one step at a time. So watch. Can everyone see where he's at right now? If I start off with moles, you can go 2 ways, right? I could ask you to solve for particles, and that's what we did yesterday, and that's what we did at the beginning of class. Or I can ask you to go to grams. In this problem, I asked you to go to grams. If I'm asking you to go from moles to grams, do we have to worry about particles at all? If I start at grams, put your finger on grams. What's the only step we can go from grams to? Moles. Now, watch. What we're going to do next class period, this is fair warning, is once we're at moles, then we can do one more step and go to particles. But again, it's just literally one step at a time. We're just adding the 2 steps together. It's not going to be that hard. But what I do need you to do is I need you to feel really comfortable doing these types of problems. How much time do you have in class? 15 minutes? Okay. Can I have you guys do some practice on these? Now, honestly, how many people actually did the homework from last night? Okay. Okay, so let's do this. I have the answer key up here. If you didn't do the homework last night, then what you're going to do is just do it right now or do portions of it. But I want you to do some of these problems as well. So I'm going to give you in the back of the book, here's your homework for next class period. Now, you're going to do your homework, yeah? I will personally check all of your homeworks, and I'm going to be really ruthless about you not doing it. I need you guys to be doing it. I feel like I'm really reaching out to you guys, right? I'm trying to help you guys out. I need to see that you guys are working. Because if you're not working, it makes me really not. What's that?
What are the most homework I've had this entire year?
I'm really sorry.
It's okay.
Okay. Your homework's going to be chapter 10. And
That's not homework.
that worksheet is going to be homework, but that worksheet does the next steps. So everyone make sure you bring that worksheet that I just gave you to class. Bring it next class period because that's going to be it will be homework, so don't worry about it. Yes. Yeah, can you just wait 1 second? Let me give you the assignment. Okay. So I would like you guys to do, so the homework from yesterday was chapter 10, problems 90 through 96. Today, I want you to do 108 through 110. And this is page 358. And I want you to do problem number 131. And 133, 134. Now, let me show you something really quickly. Can you write this on the board? So I want to show you that so you don't get confused if you see this. Can you write CuOH in parentheses too? Okay, baby U. CuOH, all in parentheses, the OH and O and the H in parentheses, and then 2. Okay, everyone look. Okay, that's a compound, isn't it? So if I ask you to solve for the molar mass of that, do you realize you have to add up all the individual atoms? But let me show you how the atoms actually work in this case. Go over there to that for you really quickly. Put your finger on the Cu. How many Cus do I have there? 1. Do you see that the 2 only applies to what? The O and the H, right? So then how many O's do I have? 2 O's and 2 H's. So how do I figure out the overall mass for that compound? Add one molar mass of copper, which we get on the periodic table, to 2 molar masses of oxygen, to 2 molar masses of hydrogen. Add them all up. Now you have the grams per 1 mole, and then don't we have a conversion? We can go back and forth in problems like this. So in all fairness, the last problems I gave you, they're going to be a little more hectic because you're going to have to go back and forth between, you have to first get the molar mass of a large. Ian, are you distracting? That's fair. Okay, everyone know what your homework is? Let's work on that the remainder of class.